Hi, I'm Cheryl Silcox. This presentation looks at new scientific theories about how we learn and retain information. We can use this new knowledge to build learning activities into our courses that will help our students with content mastery and long-term retention. Following the completion of this tutorial, you will be able to explain the processes of encoding, consolidation, and retrieval, describe the retrieval effect, differentiate between massed practice and spaced practice, and list 4 retrieval practice activities that can be included in course design. One of the most talked about ideas in recent cognitive science is the retrieval effect, also known as the testing effect. According to this theory, the more times information is recalled, the stronger the memory will be and the easier it will be to recall in the future. Additionally, it is believed that for learning to be lasting, there has to be an element of difficulty. This theory is based in brain science, so it is important that we first understand how the brain goes about processing new information. Although far more sophisticated, the brain processes information in much the same way as a computer does. Sensory input causes the brain to undergo physical and chemical changes that allow the creation of memory. Learning involves a 3-step process that takes place in the brain. The first process of learning occurs when the sensory impulses cause the brain to undergo physical and chemical changes that translate the new information into a form that the brain can understand and use. Neural pathways are established and the information is moved into short-term memory. This process is called encoding. Once encoded, newly acquired information is combined with existing knowledge by consolidation. During consolidation, the brain makes connections, fills in gaps, and creates new mental models that are stored in long-term memory. These models will later be recalled as a single unit of memory that will be more quickly and easily remembered than if it were just an assortment of random facts. Finally, during retrieval, information previously stored in long-term memory is pulled back out into working memory where it can be used to solve problems. Repeated retrieval strengthens these pathways in a way that is similar to how a muscle becomes stronger when it's exercised. The retrieval effect occurs when repeated retrieval practice results in better retention and easier subsequent recall. The repetitious recall of memory causes the neural pathways to increase in number and become stronger. Most people will say that they study best by rereading the content and reviewing their notes just before a test. This is called cramming. The problem with cramming is that it doesn't lead to durable learning. Studies have shown that cramming may lead to higher scores on immediate tests, but most of what is learned is forgotten shortly after the test. We present information in the form of lecture, then the students are tested. Once tested, the content is usually not revisited unless there is a comprehensive exam at the end of the term. Retrieval practice is a much more effective method of study. Requiring the students to repeatedly recall what they've learned helps to move the information into long-term memory and provides them with a broader foundation of knowledge on which they can build new learning. Scientists tell us that learning that is effortful is more durable. Throughout our lives, we continue to produce new brain cells. Many of these new cells died within a few weeks. Laboratory studies have shown that neurons that are used in learning not only survive, but are stronger and become part of neural pathways that we use to remember. That learning, however, has to be effortful and successful. Neurons that are used in learning that is not effortful or not useful will die. Retrieval practice should be done in short segments over a period of time. This is a much more effective form of study than mass practice or cramming. It is thought that when information recall is delayed, the retrieval is more difficult and leads to longer-term learning. Although counterintuitive, research has shown that it is best to stop studying before you feel like you've mastered a topic and return to it later for further study. If practice becomes mindless, it's time to take a break. Interleaving is a technique that involves switching to studying another topic before you feel you've mastered the topic at hand. Interleaving, it is believed, improves the brain's ability to discriminate between concepts. Practicing in this way gives the brain the ability to differentiate between types of problems and to choose which knowledge to apply to create new solutions. The brain becomes more organized and is more prepared to take on new challenges. In 2005, a group of researchers from the Memory Lab at Washington University in St. Louis approached a middle school principal and asked him to allow them to test their theories on a group of sixth grade social studies students at his school. He agreed, and an important study on the effectiveness of retrieval practice began. Quizzes were designed to test on approximately 1/3 of the material that would be covered by the teacher. The quizzes had no bearing on the students' grades, so there was no cause for test anxiety. The teacher had no idea which part of the content she taught would be quizzed. At the beginning of class, quizzes over assigned reading homework were administered. At the end of class, the quizzes covered what had been learned that day. Quizzes were also administered 24 hours before the unit exam, at the end of the semester, and at the end of the year. During the quizzes, students responded using clickers to a series of multiple-choice questions. Interspersed among the quiz questions were statements that reviewed some of the content that had been covered but was not being quizzed. The students, therefore, saw these review statements but were not asked to engage in any kind of memory retrieval with regard to them. The results of the experiment showed that students were able to remember information that had been quizzed better than the information that had not been quizzed. There was also no significant improvement in remembering the content that had been just reviewed but not quizzed. Similar results were achieved in subsequent tests that were conducted with 8th grade science students and with adult learners. This research shows us that when we design courses, we need to include retrieval practice as a learning tool that will help our students learn better and remember longer. The traditional model of lecturing, testing, and moving on to another topic isn't the most effective way to teach for lasting learning. When designing courses, we should leave time to revisit topics that we've covered in the recent past. We should incorporate activities such as frequent low-stakes quizzing, bell ringer questions, short reflective writings, and group problem-solving activities to practice content retrieval. These activities should actively engage the students and should not be so easy that they become mindless. The more difficult the learning is, the more chance that students will retain it.